Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syairah binti Ramli and our group member will explain about Hplc, which is High Performance Liquid Chromatography. So this is our group member, which is Syairah, Danish, Farah, Topet.
I will start with introduction first. Hplc it can utilize a liquid moving phase to carry the sample throughout stationary phase. How? The separation is achieved based on the differential interaction between the sample component and the stationary phase. And then analytes are typically dissolved in solvent. Then the process continues with using high pressure. For what? To force the solvent through the chromatography columns. Other at that HPLC also very versatile because it can handle compound that might be difficult for other analytical procedure. Advantage of HPLC. Firstly, greater sensitivity. HPLC offers a wide range of detectors, each with its own strengths and weaknesses. For example, ultraviolet detectors are commonly used for organic compounds that absorb light. Meanwhile, fluorescence detectors are more sensitive to compounds that fluoresce. Then HPLC also visible column. Why? Because can be used multiply time for the same analysis. In that case, can reduce the cost per analysis and minimize waste. Lastly, sample recovery. How? By allow you to collect with a fraction of your sample during separation. This is achieved using a fraction collector, which automatically collect the alien based on peak detection. HPLC applications. Firstly, in the food and beverage industry, HPLC is used to analyze the composition of food and beverage, such as detecting artificial flavor and contamination. Then, in clinical chemistry, HPLC is used to diagnose disease by analyzing blood, urine, and other biological blood. Lastly, in forensic science, HPLC is used to analyze evidence in criminal investigations such as detecting drugs and poisons.
So next, I will explain about principle of Hplc begun by insert solute at the column top. Separation happens as mobile phase move through the column. Each component elute creatively on the recorder. Detector response display as a chromatogram.
Alright guys, now let's moving to methodology for HPLC. Alright, so the first method is sample preparation, where the sample is prepared for analysis and make sure the samples are in the right form. And the next method is mobile phase, which is the prepared sample is injected into HPLC. And next is column, which is column is the crucial component in HPLC that will lead to the next method, which is separation. As the sample travels through the column, component interact differently with the stationary phase and leading to the separation. From the separation, we go to the next method, which is detector. The detector monitors the eluent coming out of the column and generates a signal corresponding to a concentration of different analyte. And lastly is data analysis, which is we analyze the data that we obtain from the detector. Alright, so let's see the detail for our methodology in HPLC, which is the filters to maintain the pure solvent and prevent the reaction in chromatography. And also degasser is ensures the stable flow, remove gases and avoid interference. Next is pump stabilize flow, prevent the pulsation in the system. And injectors introduce sample into the mobile phase. For guard column, it is extends analytical common life and prevent issues. But for analytical columns, it is stainless steel tube for precise substance separation. And for the bulk properties detectors, respond to mobile phase change. And solute properties detectors are detect unique solute characteristic. Hi guys, so for the discussion, let's discuss our past year questions from July 2021. Alright, so you guys can pause the video to see the questions. Now, let's discuss the answer for the question A. Reverse phase chromatography is indicated by the title. In this system, stationary phase is typically non-polar, which is often a hydrophobic alkyl change like C18 bonded silica, while the mobile phase is polar. The combination involves a polar mobile phase and a non-polar stationary phase. Now, let's discuss the answer for B1 and B2. Ultraviolet detectors work by measuring the absorption of UV or visible light by analytes in the mobile phase at specific wavelength. Refractive index detectors measure the change in the refractive index of the mobile phase as different analytes elute from the column. For B2, UV-Vis is generally suitable for compounds with chromophores, which is part of the molecules that absorb UV or visible light. Now, let's discuss for question C. Chromatographic resolution assesses the ability to distinguish peaks. It relies on factors like retention time and peak width. In reverse phase system, a more non-polar mobile phase leads to quicker elution of less polar compounds. Comparing benzyl alcohol and a methoxyl biphenyl, polarities helps predict their elution times. Benzyl alcohol being more polar elutes slower in a more organic mobile phase. Now, let's see the answer for question D. Chromatogram B exhibit enhanced peak separation compared to chromatogram A, indicating a successful modification in mobile phase. Typically, this involves altering the mobile phase polarity. If chromatogram A with 90% organic content show poor resolution, reducing the organic content could enhance the interaction with the stationary phase and improve resolution. The specific ratio will be required experimentation but would likely be less than 90% organic. Now, let's move into past year questions from February 2023. The first question is for A, consists two questions. The first answer is readily available in pure form, an acceptable level of toxicity, low viscosity and compatibility with the detection method. Answer for second question is a process where the dissolved gases are swept out of the solution by fine bubbles of an inert gas such as He helium that is not soluble in the mobile phase. Alright guys, so for question 4B that consists three questions. The first question is label block diagram of Hplc. So you guys can pause the video to see the diagram that we already insert in the questions. So for the second questions, the answer is the presence of particles will damage the pumping and injection system. The dust and particulate will clog the column. So for the third questions, the answer is anion exchange resin and cation exchange resin. Now, let's move to questions 4C. The answer is the fractionation occurs between a group is directly related to the molecular weight and molecular shape. The larger particles will elute first because they are too big to fit inside the pores. This is followed by the intermediate size molecules where average penetration into the pores depend on their diameter. The smallest particle will elute last because they fit very well inside the pores. So for the question 4D, there are two questions. The answer for questions number 1 is loss of stationary phase by dissolution in the mobile phase requires recoating of the support particles. Stationary phase solubility problems prohibit the use of packing for gradient elution. For question number 2, the answer is retention times become longer. Now, for the last discussion, which is past year question February 2021, that are consist two questions, which is question 2 and question 8. For questions number 2, it consists 4 questions, which is A, B, C, and D. So the answer for questions A, chromatography separates components in a mixture based on their different interaction with a special material. Each component moves through materials on its own depending on its properties. Faster moving components travel further, while slower ones lag behind. This separation allows us to analyze each component individually. For answer questions B, planar chromatography. Support material for planar chromatography typically involve a flat surface as stationary phase support materials. For example, a planar chromatography includes thin layer chromatography and paper chromatography column. Column chromatography, which is the support materials, is involve a column packed with stationary phase support material. For example, common example includes chromatography is high performance liquid chromatography HPLC and chromatography GC. For question C, you guys can pause this video and see the calculation that I already insert in this video. And for D questions, the answer is to improve separation between peaks M and N, you need to adjust chromatographic conditions like the mobile phase composition or column temperature. Now, let's move into question 8 that consists 3 questions, A, B and C. Answer for question A is, the elution technique in chromatography affect both resolution and analysis time. Gradient elution with gradual change in mobile phase composition enhance resolution but requires more time. Isocratic elution, maintaining a constant composition, it faster but may sacrifice resolution, especially for complex mixtures. This choice depends on the balance between resolution needs and time constraints. For answer for the B, size exclusion chromatography separates molecules based on their size. Larger molecules are excluded from the stationary phase, materials pause and thus elute first, while smaller molecules can enter the pause and elute later. For question number C, degassing is crucial in high-performance liquid chromatography as it removes dissolved gases from the mobile phase. This ensures a stable baseline, protects the chromatographic column from damage, and improves sensitivity by reducing background noise. Overall, degassing is essential for accurate and reliable chromatography analysis.
For the type of HPLC, actually we have 3 types, which is partition, ion exchange and size exclusion. Normal phase HPLC is our go-to for separating less polar compound using a polar stationary phase. In contrast, reverse phase HPLC excel in separating polar compound with a non-polar stationary phase. Ion exchange is our third type, focuses on separating ion based on charge interaction. Lastly, we have size exclusion, also known as gel filtration or gel permission. We separate molecules by size using a porous gel matrix. This technique offers versatile solutions for various analytical challenges. So I will explain about infinity chromatography. For the principle is, infinity chromatography separates biomolecules based on specific binding interaction. And the advantage is specific binding between analyte immobile phase and immobile ligand on stationary phase. And the procedure number 1 is load stationary phase with immobile ligand into the column. Number 2, introduce the mobile phase. Number 3, molecule binding to the ligand stay on the stationary phase. Number 4, use a wash buffer to remove non-target biomolecule with weaker interaction. Number 6, apply an elution buffer to destroy interaction and recover the target biomolecule in the eluting solution. I will explain about this. For the bind, mixture with many protein add to the column, but only target protein sticks to special ligand on bead. For the wash, unbound material wash away, but only target protein remain attached to bead. And for the elute, special solution added to release target protein. Then pure target protein collected at bottom. Next application, separate high molecular weight natural product from low molecular weight species. Efficiently separate homomer and oligomer. Quickly determine molecular weight distribution of large polymer or natural product. In conclusion, Hplc stands out as a versatile and user-friendly analytical tool with widespread application in pharmaceutical, food analysis, environmental monitoring, and clinical diagnostics and chemical research. Its efficiency in handling complex mixtures and providing high sensitivity and selectivity make it indispensable for researchers and analysis. The ongoing evolution of Hplc technology ensures its continual relevance and addressing diverse analytical challenges across various industries. Thank you for listening, and that's all from our group members.